Hello and welcome to my channel. Please don't leave the video. This episode is about the formation and atmosphere of Earth. Let's dive in. Formation of Earth's atmosphere. Earth's atmosphere formed about 4.5 billion years ago, along with the planet itself. Initially, it consisted of gases released from volcanic eruptions, such as carbon dioxide, water vapor, ammonia, and methane. As the Earth cooled, water vapor condensed into oceans, and chemical changes and biological activities, like photosynthesis, produced oxygen, leading to the atmosphere we know today. The water cycle. Water is a key component of the water cycle and spends a significant amount of time in the atmosphere, mostly as water vapor. All weather changes occur within the Earth's atmosphere. In essence, weather determines the atmospheric conditions at any given place and time, including temperature, wind, and rainfall. The long-term average of these weather changes defines a region's climate. The role of the ozone layer. Ozone is a molecule made up of 3 oxygen atoms. This layer in the Earth's upper atmosphere absorbs high-energy ultraviolet rays from the sun. It protects living organisms on Earth from harmful solar radiation. Without this shield, only a few species could survive on the planet. Composition of Earth's atmosphere. Nitrogen and oxygen make up about 99% of the Earth's atmosphere. The remaining gases exist in trace amounts but play crucial roles. Humidity refers to the amount of water vapor in the air, which varies by location and season. Some substances in the atmosphere aren't gases but include dust, soot, ash, salts, metals, and other solid materials that make up a tiny fraction of the atmosphere. These particles are vital in initiating water vapor condensation and forming raindrops. When humidity is high, the air feels heavy, while dry air feels more comfortable. High humidity is common in tropical regions, where warm temperatures retain more moisture in the atmosphere. What are the layers of Earth's atmosphere? Troposphere. The troposphere is the first layer of the atmosphere as we move upward from Earth's surface. It has the highest temperature at ground level, which decreases as altitude increases. The temperature gradient is about 6.5 degrees Celsius per 1,000 meters. This means for every kilometer upward, the temperature drops by 6.5 degrees Celsius. The main source of heat in the troposphere comes from sunlight absorbed by Earth's surface, rocks, soil, and water, which is then re-radiated back into the troposphere. Warm air near the surface rises, while cooler air descends, creating unstable conditions. This mixing is responsible for the various weather phenomena, such as rain and snow, which all occur in the troposphere. Sometimes, temperature inversion occurs, where warm air lies above cooler air, creating stable conditions that may trap pollutants and lead to air pollution. At the top of the troposphere, a boundary exists where temperature remains constant, separating it from the next layer, the stratosphere. Stratosphere. The stratosphere lies above the troposphere and is the second layer of Earth's atmosphere. Volcanic gases and ash can reach this layer, where they remain suspended for years because the layers of the stratosphere and troposphere rarely mix. The stratosphere is much calmer than the troposphere, which is why airplanes often fly at this altitude. The primary heat source in the stratosphere is the sun. This layer is more stable due to warmer, less dense air above cooler, denser air. Between 15 to 30 kilometers in altitude, the ozone layer is found, absorbing harmful ultraviolet rays from the sun. The thickness of the ozone layer varies with altitude. Mesosphere. In the mesosphere, temperature decreases with altitude. Since this layer contains very few gas molecules to absorb solar radiation, its heat source is the stratosphere below it. The mesosphere is extremely cold, with temperatures dropping to -90 degrees Celsius. The air density in this layer is incredibly low, and 99.9% of Earth's atmospheric mass lies below it, resulting in very low pressure. The ozone layer does not exist in the mesosphere, so protective equipment is needed to shield against ultraviolet radiation. Thermosphere. The thermosphere is characterized by its extremely low molecular density, where a single molecule can travel up to a kilometer before colliding with another. Consequently, very little energy is transferred, and the air appears extremely cold. Within the thermosphere lies the ionosphere, so named because solar radiation ionizes its molecules, turning them into positive ions. These free electrons and ions allow the ionosphere to conduct electricity. At night, radio waves can bounce off the ionosphere and return to Earth, enabling AM radio signals to travel vast distances from their source. Van Allen radiation belt. The Van Allen radiation belt is a region filled with charged particles trapped by Earth's magnetic field. These particles originate from solar radiation and are transported toward Earth during solar winds. When these particles become trapped, they spiral along Earth's magnetic field lines. During intense solar storms, the density of these charged particles increases, resulting in phenomena like auroras. These particles travel along magnetic field lines toward the poles, creating the stunning light displays of the aurora borealis and aurora australis. Aurora's charged particles transfer energy to nitrogen and oxygen gas molecules, causing them to emit light. Each gas produces a distinct color, creating the mesmerizing auroras. Exosphere. The exosphere is the outermost layer of Earth's atmosphere. Gas molecules in this region are so sparse that, at times, there may be no gases at all. Due to the lack of molecular collisions, lighter and faster atoms like hydrogen and helium can reach escape velocities and leave Earth's magnetic field. This layer starts at approximately 500 kilometers above Earth and extends to the interplanetary medium. The temperature in the exosphere remains nearly constant, averaging around 1,500 Kelvin, and does not vary with altitude. Heat transfer in Earth's atmosphere. Heat transfer in Earth's atmosphere occurs similarly to heat transfer on the surface. It happens through three main mechanisms: radiation, conduction, and convection. Conclusion: the Earth's atmosphere is not just a shield for life, but also a story of our planet's past and future. Yeah, the video. Check it out on the Puzzle of Evolution YouTube channel.